Welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. So we're going to conclude Chapter 4 by going through and looking at a few examples of Boolean expressions and using if, just to give you a bit more practice and show you some things that aren't in the book. So the first example that I want to do is I want to write a little script where the user will input the sum of grades and how many grades there were, and we're supposed to give them an average, and then also give them a letter grade. Right now we're kind of limited on the ability to we can't ask for either a variable number of grades yet. We'll learn how to do that in the next chapter. So instead of having the user input individual grades, where we assume we know how many, we're just going to say you input the sum of the grades and how many grades there were. For one thing, it's helps to illustrate things for this particular chapter. So we'll prompt the user. And they are supposed to enter in, and we'll go with an integer, and this will also help us illustrate some things. How many grades went into that sum? That value is definitely an integer. And then the first thing that we should print out is their average. And so print line okay. And if we run this, some of the grades, let's say that you came out with 189 in 2 grades, and so you had an average of 94. Now, two things to note here. So, well, there's one thing to note with this example. First off, that is not the average. The average is actually 94.5. Why did we just get 94? Well, because both grade sum and num grades are of type int. When we do division between them, we are doing integer division. And so we could fix that, for example, by converting this to a double. The code we have here does happen to have one possible problem with it. And you might think that this shouldn't really be a problem. No one would ever be dumb enough to do this. But what if you were calculating a grade early in the semester where you haven't done anything yet? Well, that causes a problem for this. It turns out that doing integer division by 0 is problematic. So how can we prevent that from happening? Well, one way of doing that would be to have an if, and if num grades is less than 1, then we're going to have one branch of logic, else we are going to print their average and possibly other things. So what should we do here? Well, I'm perfectly good with printing a message that says that they really don't have any grades yet, and so you can't have an average. And then you're done, because not only are you not going to print the average, you can't print a letter grade or anything along those lines. How would we fix this? Well, as we saw previously, if we convert one of these to a double, then when we run through the math, like 189 and 2, we get a double value, which prints out with the fractional part. And if they are both zeros, we get that branch. So now after printing the average, I would like to also print out a letter grade for that. Print line letter grade is, and then we'll just clean up the formatting a little bit. I generally don't care too much, but you know, maybe you want to do that, and it's good for you to see that you can add in additional strings at the end for concatenating. Now this assumes that I have a variable called letter grade, and so somewhere right before this we need to make a variable for letter grade. First, let's comment that out just to show you what error message you would get if we didn't. So right now it's getting to this line and it says that their error not found value letter grade. Has no idea what letter grade is because we haven't declared a variable called letter grade. Sorry. So letter grade equals, how are we going to do this? Now I'm going to use both to keep it somewhat short and simple, I'm going to use a standard scheme of above a 90 is an A, 80 to 90 is a B, 70s are C's, 60s are D's, and anything below a 60 is an F. Now you should see the way I'm writing this right here, I need an expression over on this side because I am setting letter grade equal to something. Whatever appears on the right hand side of that equal sign has to have a value to it. I'm perfectly willing for that value to be either a char or a string with the letter that I want to come down into here. And this is interesting to note that here I'm using if as a statement. This if doesn't evaluate anything, it doesn't give us back anything. Here I need to use if because I have all these different options. I need to use the if in a context where it is going to give us back a value. And so I am going to use it as an expression here. Well, now something to note here is that I need to base this upon that expression right there. And so I could say, well, if, and then have that is greater than 90, it gives you an A. Else, if the same expression, the same expression, same expression. If I'm going to be evaluating that expression many times, it is probably better for me to create a variable with that name. And that way I can just refer to that variable. It'll be shorter, it'll be easier to read, might potentially save computer speed, though it turns out that many compilers will figure out what's going on there and make it happen as a single evaluation anyway. So if the average is greater than or equal to 90, then your grade is an A. Else, if the average is greater than or equal to 80, you get a B. Else, if average is greater than or equal to a 70, you get a C. Else, if average is greater than or equal to 60, you get a D. Else, you get an F. Now there are some things worth noting in this code. We should actually, before we go through it too much, prove that it does what we want. So 189 and 2, what we've been doing before. What if we had 189 and that was 4 we're using this as an expression here, which means that the last else has to have a value here. You always have to have an else when it's an expression. Otherwise, what would happen if your last if were false? Also, I'm using a little syntactic shortcut, which is actually very commonly used, not just in Scala, but in other languages that have a similar if structure, where when you have the else block has an if inside of it, instead of nesting it inside further, you simply put else and if, and then you have a block for the if, and then else and if, and a block for the if. Otherwise, all of these would be nested inside, and they'd be tabbed in, and it gets a lot more difficult to follow and to type in and to keep it nicely arranged. This is a very standard format that programmers use if they have the only thing inside of an else block is another if. The other thing that you might notice, well, what are the requirements for a grade to be a B? Well, a grade is a B, definitely if it's greater than or equal to 80, but it also needs to be less than 90. And it might at first bother you that I didn't put if average is greater than or equal to 80 and average is less than 90. Now, this code will still work just as well if I put this in here, but it turns out it's superfluous. This check right here isn't needed because this if is after the else here, and that else is on a check for average being greater than or equal to 90. If average were greater than or equal to 90, we would have gotten A here, and none of these other ifs would have been checked. So I don't have to check to see whether the grade is less than 90 for the B, because basically I already did that when I ruled out the A on the line above. And then similarly for the C, at that point I've ruled out an A and a B, so I know this grade is not 80 or greater, so I just have to check to see if it's greater than or equal to 70. And then same type of thing goes for the D. Anything that doesn't pass one of these four criteria is automatically an F. Okay, so that's a little script showing you the way that some more uses of if associated with grades. There is one other thing that I will do, and I'll do this real quick in the REPL. Let's assume that we have a point, so let's see, val points equals 189, val grades is 2. I'm using shorter names here for the REPL. And all I care about here is whether or not you got an A. Maybe we're doing some check where we don't really care what the letter grades were for anything else. We just want to check if it was an A. We don't have to calculate the average separately. And so it's tempting to write if points divided by grades is greater than or equal to 90, then print line, you win. Okay, and of course here it is. But what happens with this code if we do that? Well, we've seen this blows up. We got a division by 0 here. So how do I need to protect this? Well, you could say, well, you put it inside of another if, but I don't have to do that. Turns out that I can say I only want to print you win if grades is greater than 0 and points divided by grades is greater than or equal to 90. Now, when you read this, at first you might worry that this will still crash, because if it does both of these, if it evaluates grades greater than 0 and it does the division, it would still crash. But it turns out it won't. Okay, and the reason it doesn't is because the and as well as the two-pipe or are what are called short circuit operators. And what that means is that if the result can be determined from the first argument, it doesn't calculate the second argument. Now in the case of an and, if the first argument is false, it doesn't matter what's over here. The whole thing is going to be false because false and anything winds up being false. On the other hand, with or, if the first argument is true, it doesn't matter what the second argument is, and so it won't be evaluated. This winds up being very handy for expressions like this. So I don't have to take an if and then nest another if inside of it. I can just use the and here, and that will evaluate the first one. And then if it's false, not evaluate the second one. So that when you have situations like this where the first operator can be a check, or the first argument to the and can be something where if it's false, the second one would fail, would crash. This, using the short circuit properties of the and, makes it so that you don't have a crash there. All of the examples that we've done so far are numeric in nature. And just real quick, I want to write an example that isn't numeric. It's a very simple example. It's actually something that we've used at Trinity for our high school programming competition in the past. There's this idea of what's called the game. And actually this came from a year when we used all XKCD based problem sets, and if you look at the XKCD webcomic and the game, if you do a search for that, you should find the comic that we were referring to. The game is one of these, it's a silly idea. When you play it, the way to win is to not think of the game. As soon as you think of the game, you have lost the game. Those are the rules for the game. So at least in our problem that we gave to students, the question was, you're given a string and you have to run this program to see if it's safe to read it, because if the string says the game in it, by reading that you will have lost the game. Now, of course, the proviso here is that by thinking of running the program, you've already lost the game. But we'll ignore that, and we'll say that for some reason this script happens to run through everything that is going to go through I don't know. Anyway, but it deals with strings instead. So we're going to read in a line of text, and we're going to use read line. So far we've primarily been reading numbers, read int or read double. Read line just reads in an entire line of text. And I want to do a check to see whether or not that line of text contains the game. So we'll write a first version of this. If line of text dot contains the game, print line, you lose, else print line, you win. Okay. Simple little example there, and I can run it. Oh, I didn't put a prompt. How about this? Print line, what are you thinking? Okay, so if this is a test, you win. I wonder if I won the game. You lose. You might notice something about this though. Okay, that's not how I would normally enter that. Normally I would enter, I wonder if I won the game. Okay. That says I won, though clearly I didn't. I mentioned the game in here. And the reason we have a problem here is that this contains is checking against this very particular string here, which has a capital T and a capital G. And if I made it so that it was lowercase, well then this one would say I lost, but this one would say I won. I really want to ignore capitalization. So how could I do that? Well, you can think about this for a little while. And it turns out there is a comparison between strings that ignores capitalization, but I don't want to compare whole strings. I just want to see if there's a string inside of another string. And one way of doing this in a way that does not include case is I'm going to make the thing I'm comparing to all lowercase, and then I want to take the string that, that the user entered and make it lowercase. So there is a method on string called toLowercase, which will convert whatever you've typed in all to lowercase. And then we're doing a check to see if it contains something, which is all lowercase. And so now if I do this, now of course if it's all lowercase to start with, you would expect that to say that we lose. Note here, I capitalized the T because it's at the beginning of the sentence, but I didn't capitalize the G in game, and it still worked. It still found it. This does raise the interesting question. Two tests where it both says you lose does not mean the code works. Okay. We also have to show that you can win as well and get the other branch. So that's a very simple example of using an if with something that has absolutely nothing to do with numbers, and we're not doing any arithmetic here. This is doing string comparisons and reading stuff in. We still have this very significant limitation right now, which is that I can't repeat code. And we will see over the coming 3 chapters 3 different ways of getting code to repeat. We have one more chapter where we're going to talk about functions and breaking problems up, and then we're going to have 3 chapters where we look at different ways where we can get code to repeat and do other stuff along the way. So that will give us significantly more capability. Starting with the next video, we'll look at how we might take the things that we're writing here in scripts and break them up into functions, which would hopefully be more usable and reusable to simplify our programming over time. So that's it for this video. See you again soon.